Welcome back to Math 103. This is video number 3 on apportionment. At the end of the last video, we were looking at several non-political examples and understanding the relationship among seats, states, and population. The question was, in each of these examples, we are told what are the seats and what are the states. Okay, seats are apportioned to states. The question is, what should that apportionment be based on? Right? So buses are apportioned to bus routes based on riders. That's a reasonable answer. The more people ride the A bus each day compared to the B bus, the more buses should be allocated to the A route compared to the B route. Now, just to clarify, because students often get confused about this, what's the relationship between seats and states? So exactly which is which in a typical example. So why is it the buses are the seats and the routes are the states instead of the other way around? Because each bus is allocated to, apportioned to one route. One route can receive many buses, just as one American state can receive many congressional districts, but each seat goes to one and only one state. And so they're not playing the same role here. So next example, nurses are allocated to hospital shifts based on patients. The more patients there are on one shift compared to another, the more nurses should be apportioned to it. Police officers are apportioned to neighborhoods based on incidents, perhaps. That's not the only possible answer. Right? It could be based on population in the ordinary sense. It could be that the more crowded the neighborhood is, the more police officers are apportioned to it. Or you could say that the more crimes are committed, the more police officers should be apportioned. There's more than one possible answer here. Faculty positions are allocated, that is, apportioned to university departments based on, well, one very plausible answer is enrollment. The more students there are taking math courses, the more faculty positions there should be in math. Candy bars are apportioned to children based on, well, there are many answers here. I had in mind minutes spent doing homework, but that's just me. Sales personnel are allocated to retail stores based, for example, on customers, in the sense that if there are more customers at one location, typically, then you want to have more sales staff there. And computers are allocated to campus computer labs based on, well, it would make sense for that to be based on the number of users. The more people who are actually going and using one computer lab instead of another, the more computers it makes sense to have at the more popular computer lab. So back to our political example. It would be too much work for our purposes to analyze the entire United States, so we're going to look at a simpler example just involving the states in New England. So this will be our recurring example. We suppose that Massachusetts, Connecticut, Maine, New Hampshire, Rhode Island, and Vermont secede and form a new country called Red Sox territory. The idea will be that there is only one baseball team, the Red Sox, and they'll have an event that they call the World Series, and this way the Red Sox will win every single year. Now, the idea here is that their legislature in this new country is modeled on the U.S. House of Representatives, or one half of their legislature is modeled on the U.S. House of Representatives, and it has a total of 25 seats. In other words, in this entire country, there will be 25 congressional districts. The problem of apportionment will be to give out those 25 seats to the 6 states based on population. Now, the population of each state, based approximately on actual census data from the year 2000, is given in this table. So we're given the number of seats, and we're given the population of each state. And so now our problem is, how exactly are we going to give out a whole number of seats to each state so that the total number of seats given out adds up to exactly 25. Now, there are going to be different approaches to answering this question, but I caution you, every state has to receive a whole number of seats, as we've remarked, but also it's important that the total number of seats apportioned really does come out to 25. I mention this because it's a common mistake. If you write down what you claim to be an apportionment of the seats, and it does not add up to exactly 25, there is a mistake. So always check to make sure that you're allocating all the seats and exactly that correct number of them. Now, the problem that we've just stated for our 6 states in the newly formed nation of New England, and our other example from before about computer sales and allocating iPad minis as a bonus, it's worth pointing out that mathematically these are equivalent. Right? That's actually why these examples were set up this way. And so Matt sold 63 computers. That corresponds to Massachusetts having population 6.3 million. Right? So in the population, every 100,000 people correspond to one item here in the computer sales. So in both cases, it is exactly 25 items that need to be allocated based on population in the ordinary sense here, and population in a different sense in the computer sales example. Notice Matt, Massachusetts, Connie, Connecticut, May, Maine, Newt, New Hampshire, Rose, Rhode Island, Vern, Vermont. You might think that's corny, but if you were a math professor, you'd think that was hilarious. So to come up with a precise number of seats to give each state in either version of this example, we're going to need to know what is the total population, so that we can talk about Massachusetts' share of the total population, 13.9 million. We'll talk about Connecticut's fraction of the total population. Similarly, in this version of the problem with computer sales, the total number of sales is 139. And so we're going to ask, Matt is responsible for what fraction of the total number of sales? Alright, so our first approach is going to be to find each state's proportional share of the total population, and whatever each state has as a fraction of total population, we're going to try to give that state that very same fraction of all the seats. Right? If your state has a quarter of the population, it is in some sense entitled to a quarter of the seats. If you have half the population, you should get half the seats. If you have 2/3 of the population, you should get 2/3 of the seats. So we're going to need to answer the following specific questions. What's the total population? Okay, we just did that for our example. For each state, what is its share of the total population? In other words, what is its fraction of the total population? We might express it as a fraction, or it's more useful to express it as a decimal, or perhaps as a percentage. These are all mathematically equivalent. And then once you know what fraction or percentage of the total population each state has, then we want to go and compute for each state what's that same fraction or percentage of the total number of seats. So for example, Massachusetts, in our example, it has 6.3 million people out of a total of 13.9 million people. So what is its share of total population? Well, 6.3 million out of 13.9 million, that's 0.4532 of the whole. In other words, Massachusetts has 45.32% of all the population in New England. Okay. So if Massachusetts has 45.32% of the population, then it is entitled to that same fraction of all the seats, according to this way of thinking. And what's 45.32% of all the seats? It's 0.4532 times 25 seats. That's 11.33 seats. It's very important to understand this, right? If you have 45.32% of something, that's the same as 0.4532 times that thing. All right. Now notice the analogy here to something that we did in the last chapter. In the last chapter we said that if you're, say, a district of a county with a certain percentage of the total population, then in some sense you're entitled to that same percentage of the actual power in the county council. Well, it's the same thinking here. Whatever your percentage is of population, you're entitled to that same percentage of the number of seats. Now, before going on to the next video, please complete this table, and that means finding, for each of the remaining states, we've already done Massachusetts, but for each of the remaining states, what is its fraction of the total population of the region? In other words, answer this question for each of the other states. And what is its exact proportional share of the 25 seats based on population. So the same way that we took this decimal times 25 seats to get Massachusetts' exact proportional share of the seats, do the same for the remaining states.